Hello and welcome everyone. My name is Mona Yadav and in this video we will be learning about surface tension. So what is surface tension? First of all, it is denoted by sigma and it is defined as the tensile force acting on the surface of a liquid in contact with a gas or on the surface between two immiscible liquids such that the contact surface behaves like a membrane under tension. So basically surface tension, the word suggests that surface is experiencing a tension. Surface tension means surface is experiencing a tension. And this surface tension is defined as the tensile force acting on the surface of a liquid. So tensile force is what? So tensile force is kind of a stretching force which acts on liquid surface. And this stretching force generally has two components, tensile stress and tensile strain. But this means that if a particular surface is under a tensile force, is under the influence of a tensile force, that means that the surface is under tension and the forces are trying to stretch that surface. The forces are trying to stretch that surface. So the tensile force acting on a surface of a liquid in contact with a gas or on the surface between two immiscible liquids, the liquids which are not dissolvable, such that the contact surface behaves like a membrane under tension. So the contact surface or the top surface of the liquid, it will behave, the contact surface will behave like it is a layer or it is a membrane which is under a tension, which is experiencing stretching forces. Now surface tension is the tendency of a liquid surface, is the tendency of liquid surfaces at rest. Surface tension is what? It is the tendency of the liquid surfaces at rest to shrink into the minimum surface area possible. So because of this tendency of the liquid surfaces, that is surface tension, the liquid surfaces have a tendency which can shrink them into minimum surface area possible. Next is surface tension is what allows objects with higher density than water, such as razor blades and insects, example water striders, to float on a water surface without becoming even partly submerged. So when the insects are able to move on the surface of water without getting submerged in it, so this is happening because of surface tension phenomena. So the magnitude of this force per unit length of the free surface will be equal to magnitude of the surface energy per unit area. So the magnitude of this force per unit length, that is surface tension, which is expressed in terms of force per unit length of the free surface, it will be equal to magnitude of the energy possessed by this surface per unit area, surface energy per unit area. Now it is denoted by sigma, surface tension is denoted by sigma and expressed in Newton per meter in SI units form. As it is force per unit length, so it is expressed in Newton per meter. Now surface tension is defined as the tensile force acting on surface of a liquid in contact with a gas or on the surface between two immiscible liquids, such that basically the surface tension can act on the surface of water or the surface of liquid because liquid surface is in contact with the atmospheric air. The surface is also in contact with the circumferential region of the object in which it is present, the vessel or any beaker or container in which the liquid is present. So the liquid is in contact with the surface of the container also. Whereas another case may be when two liquids are in contact with each other. So the region between these two liquids will also act as a membrane under tension. So now let's try to understand this with the help of this diagram. So the phenomena of surface tension. So we are learning about the surface tension. So the phenomena of surface tension is explained by this figure. Now we are considering three molecules of liquid. Say A, this is A molecule, this is B molecule, this is molecule C. So we are considering three molecules of a liquid in mass of liquid. The molecule A, first of all, let's talk about molecule A. So the molecule A is attracted in all directions. We can see that the arrows are equally separated and the molecule A is attracted in all the directions equally by the surrounding molecules of the liquid. So this results in the resultant force acting on the molecule A. The resultant force which is acting on the molecule A is 0. But what about molecule B? So in case of molecule B, which is situated near the free surface, is acted upon the upward and the downward forces. But these upward and downward forces are not balanced, imbalanced. They are imbalanced. So these upward and downward forces are imbalanced. We can see that the downward forces are more dominant as compared to the upward forces because of the shape of the molecule B, which is situated near the free surface. Thus, a net resultant force on the molecule B is acting in the downward direction. As the downward direction forces are more dominant, so the resultant force acting on the molecule B will be on the downward direction. Now, what about molecule C? So, molecule C is situated on the free surface of liquid. So, it does experience a resultant downward force. We can see that the forces are mostly in the downward direction. Therefore, it is experiencing a resultant downward force. So, all the molecules on the free surface experience a downward force. We can come to this conclusion that all the molecules on the free surface experience a downward force. Thus, this free surface of liquid, it acts like a very thin film, but this thin film is under tension of the surface of the liquid. Thus, the free surface of liquid acts like a very thin film under tension of the surface of the liquid, and it acts as though it is an elastic membrane. So it acts as an elastic membrane which is under tension. So we can come to a conclusion that these downward forces are pulling this free surface also. These downward forces are pulling this free surface also. So that's why this free surface is acting under tension, like it is being stretched in the downward direction. So let's try to understand the surface tension on a liquid droplet. So here in the diagram we can see that there is a liquid droplet. This is a liquid droplet of radius r. So considering a small spherical droplet of liquid having a radius r. Now on the entire surface of the droplet, the tensile force due to surface tension will be acting. Let sigma is the surface tension of the liquid. P is the pressure intensity inside the droplet in excess of the outside pressure intensity, we can say. D is the diameter of the droplet. Let this droplet, which is having a diameter d and radius r, is cut into two halves. So the forces acting on one half, we are now studying about, let the droplet is cut into two halves. So the forces acting on one half will be, number one, tensile force due to surface tension acting around the circumference of the cut portion. Here, how the surface tension is represented. So tensile force due to surface tension is acting around the circumference. It is acting on the circumferential portion of the cut section. So it is expressed as sigma into circumference. So sigma into pi d. Now second will be the pressure force on the area pi by 4 d square. Now we have considered the circumference, but what about the circle? What about the inside part? So on this inside part, the pressure force will be acting. So pressure force on the area pi by 4 d square, that is on this inside circle. Now this is the liquid droplet, so it is filled with water. So on the inside circular section, we will have pressure forces. So pressure force on the area pi by 4 d square, so it will be represented by P into pi by 4 d square. Now how we came to this formula? So we know that P is equals to F by A. Pressure is equals to force upon area. So if we want to calculate force, so it means that force will be equal to pressure into area. So that's why this formula is in this way. So now equating these two things, equating this tensile force and equating this pressure force, what we have is P into pi by 4 d square equals to sigma into pi d. Now on simplifying we get it as P is equals to 4 sigma into pi d divided by pi d square, and on further simplification we can have the formula P is equals to 4 sigma by d. So this is the formula for calculation of pressure in case of surface tension on a liquid droplet. This equation shows that with the decrease of the diameter of the droplet, pressure intensity inside the droplet increases. Now let's talk about next, surface tension on a hollow bubble. Now the surface tension on a hollow bubble this case can be very similar to the case of liquid droplet. But in case of liquid droplet, what we have is the droplet is filled with the liquid. But in case of the hollow bubble, what we have a circular region, spherical region at outside and a spherical region at the inside. The hollow bubble is hollow from inside. So it will be having two surfaces, the outside surface and the inside surface. So in this case we can consider the same things as we have studied in liquid droplet. Just we have to multiply it by 2, because whatever forces are experienced on the circumference, they are multiplied by 2 now, because there are two surfaces, inside surface and outside surface. So P into pi by 4 d square is equals to 2 into sigma into pi d, which on further simplification we get it as P is equals to 8 sigma by d. Next is surface tension on a liquid jet. So we can understand this by having these diagrams. So this is the representation of liquid jet with diameter, which is having a diameter d, and the length is considered as L, and it is also cut into two halves. So let's study about it. Let sigma is the surface tension of the liquid. P is the pressure intensity inside the liquid jet above the outside pressure intensity. D is diameter of the liquid jet, and L is the length of the liquid jet. So force due to pressure will be P into L into D. So P, the pressure, into area. So area is length into diameter when we will be considering the rectangle. So it will be length into breadth. So length is L and the width is D, that is diameter. So P into L into D. And force due to surface tension will be sigma into 2L. So here we will be having the length, but the length is on both the sides. So that's why 2L. So now after equating these two things, we will have P is equals to sigma into 2L by L into D. And on further simplification, we can get it as P is equal to 2 sigma by D. So this is the formula for calculation of pressure in case of a liquid jet through the surface tension. Thank you.